Okay, question question 246 here. What we have is we have this situation where we're going to need to think about um, sort of a merged, a weighted contribution to sales ratio. And I'm sure you've read the question. What they're trying to get us to do is to sort of apply that principle to this scenario where you have these marathons. You have it tells us that you will have maximum entries of 20,000 for full marathon and 14,000 for half marathons, and they give us some variable costs. Oops, sorry, they give us some individual variable costs, if you like, to work with, but they also give us some fixed costs. So we just have to take it step by step, and let's kind of take that. So let us go to the first one. I will just open up a new screen here. So if we look at the oops, sorry, discard. Let's get rid of all of that. So let's look at the first question here. So again, please, I'm just working through my pages because I don't want to keep flicking over, and I'm sure you have. So the first question says, if Hare decides to host only the full marathon, what is the margin of safety? Well, here we have a selling price, we're told, of 55, and we have these costs, if you like, the race pack and the water stations of £15.80 and the cost of £2.40. That together brings us into the realm of £18. This is £18.20, and therefore the contribution is £36.80. So we know what the contribution is. We're assuming this is the only product we're selling for now. So therefore, we know the full costs are given to us. We have 300,000, we have 50,000, we have 30,000, we have 5,000. Altogether, that comes to 385,000. So when we divide the 385,000 by the 36.8, we get 10461. Yes, let me just do that again, just be very sure. 385,000 divided by 36.8, and we get 10,460. I'll probably say 10,462 races. I'll round it up to that. Okay, great. So what are we saying? You currently can break even at 10,462, and you can sell up to 20,000. That's your plan, 20,000 races. So your margin of safety, basically, you can fall by this difference, which is you can fall by 9,538 races before hitting break even. You have that sort of safety net. So what does that mean? That technically means as a percentage of what you can fall from, which is the whole idea. You can fall from this, if you like. That's your kind of percentage margin of safety when you do this as a when you do this calculation. Where are we here? This calculation, you will have 99538 divided by 20,000 gives you roughly 47.7%. So that's the answer there for the first one, right? So that's just your classic margin of safety question. Here we have to just be a bit more clinical with question 2 onwards. Again, the question is now asking us to now apply this principle, because again, like I say, you have to think about it weighted. You cannot imagine you're selling lots of donuts and very few pies. You cannot just add them like 1 plus 1. No, we have to kind of think of that combination that we're dealing with, which is and here we're told that we're selling 20,000 of full marathons and 14,000 of half marathons. So my options are that I do the whole thing. I could, or just deal with it individually. Kind of find a ratio. This is the ratio, right? 2 to 1.4. And just kind of just deal with it on that basis. So I'll get my contribution, I'll get my revenue. I can create a little box, all right, and then I'll have my total over here. of what's going on. So let's look at what's going on here. So in terms of my contribution, I'm told that I sell each, in terms of my revenue, I'm told that I sell each for £55, right? So for two of them, this is, so 2 times 55, which is 110. And 1.4 times 30, which is 42. That's what I'm doing right now, isn't it? In terms of combination. 2 to 1.4. Two of them, 110 and 42. So I have my total, which is 152. My contribution, if you like, is 2 times, we just worked that out a second ago, 36.8, which is, which was 2 times 36.8 gave us 73.6. And here I have 1.4. And the contribution for the half marathon, if you look at it, you have the contribution for the half marathon. We're told that you're selling each of these things for 30, and it's costing you £10.80 and £1.20, which is 12. So the contribution is 18. So you have 1.4 times 18, which is 20. 1.4, which is 25.2. So you have a total contribution of 98.8. So this, well, revenue or sales, this becomes the new C over S ratio, 98. Imagine this was basically one product. This is your new C over S ratio. 98.8 divided by 152 gives you 0.65. We're going to be using this. This is our key, and this is what you're always trying to find. Just find that and you're done. So let me apply that now. I'll keep that as well. If I apply that now, again, here, new slide, what I now have is this picture where I have, it tells me that so again, remember that at break-even, the question is asking what's happening at break-even. And at break-even, I know that contribution is equal to fixed costs. Right? And I know that contribution and fixed costs are equal to 385,000. And I know the relationship between contribution and sales is 0.65. So therefore, if contribution is 385,000, I can find what the sales is at break-even. Sales are at break-even. So therefore, the sales, if you like, at break-even are 385,000 divided by 0.65, which takes us to 592,000. And we're done. And that's that. And that's question 2. Question 3, let's just push this a little. Nothing again crazy. It's just kind of sticking with just understanding exactly what it is you're doing. So let's look here. So now we're told that, oh, you now have this additional, you have this total profit of 500 you need to also get. If you remember, the whole idea is that, well, if I know that my fixed cost of 385,000, and I also, the relationship stays put, that's C over S ratio, and I have this additional profit I need to find as well. Technically, this could be considered a fixed cost because it's a target now, just like fixed costs are a target. So this is technically the contribution you need to hit before you're happy, which comes to 885,000. So therefore, the revenue at this point that we need, if you like, to achieve this is 885 divided by 0.65. I mean, we've done it at break even. We can do it at any revenue, at any contribution, sorry. So 885,000 divided by 0.65 gives us 1361538. So we now have our revenue. Wonderful. Now, we know that our revenue, if you like, in terms of the bundles, right, was that we had revenue, it was this ratio 2 to 1.4. So we had revenue in the ratio 110. This is how we're selling these things in these packs. 110, if you like, to 42. That's the way we're selling these. We know that for every bundle of 152 in here, 110 will go to full marathons, 42 will go to half. That's the way we're selling them. This is the bundle. So we can't split this based on, I'm not sure, it can only be split on the bundles. So the question here is, well, basically we have 110 over 152 and we have 42 over 152. So that's how we need to kind of split this thing up, if you like. And when we do that, times 110 divided by 152, we have, for the full marathon, we have 985,323, and for the half marathon, we will have 136,1,538. We will have 376214, if you like. So now we have the revenue figures, and we know how much we sell each for. We sell each these for 55. We sell this for 30. So basically divide that by this by 30. You get here you get 12540, and divide this by 55, and you get 17915. So that's kind of the sequence. I think it's just getting you there. To be fair, there are probably other ways of looking at this, but I think this is probably your easiest method. I think the key point is recognizing that combination. This is the bundle, and when you recognize that, I think you're there. It's just the bundle, but this is revenue, so you need to find the revenue bundle. Therefore, when I say the revenue bundle, the revenue relationship. Yeah, I think that's one way to do it. I imagine you could do it looking from the contribution relationship, but I think this is enough. Okay, great. In class, we can try it in other ways. Right. Okay, then let's look at the next question. The next question, I will keep this. The next question comes out telling us to. Yes, this next one, I think what I did was, maybe because I'm in exam mode. In exam mode, I don't usually like guessing. I just do it. So I'll just sort of literally just do it myself. I'll sort of say, okay, you know what, I'm just going to do it. I probably could find it without doing it, probably, most likely. But I just actually test it. So currently, it tells me that I have these scenarios here. Race entry fee is £20. So I find out what the situation is before change. So I find out, well, okay, 48,000 divided by 20 minus 8. So 48,000 divided by 12. 48,000 divided by 12. And that's 4,000. So I have my break-even revenue. Sorry, my break-even volume right now at 4,000 units, and my break-even revenue at my break-even revenue. So if it's 4,000 units break-even volume at £20 each, break-even revenue is 80,000. I just have that. So I'm like, okay, I know what's going on right now. Volume 4,000, revenue 80,000, and then I increase everything to see, and then I'll see for myself whether things do change. It tells me everything goes up by 10%. Okay, so that means that my fixed costs have gone up by 10%, so they've gone up 48,000 plus 4,800. Okay, I'm ready. And then I know that my revenue has gone up by 10%, so that's now 20 plus 2, right? 22. And I know that my variable costs have also gone up by 10%, which is now 80p, and that's 8.8. So what do I have here? I have here, and on the top, I have 800. 8 plus 4 is 12. So 52,800 divided by 22 minus 8.8, which is 13.2. So I have 52,800 divided by 13.2, and I have 4,000. So this gives me 4,000 in terms of break-even. So break-even is also 4,000. But then if I multiply 4,000 times 22, I get 88,000. So what can I say? I know the break-even volume has not changed, but break-even revenue has changed. I've just done it. You can probably do it yourself quickly, faster than I have, but I think it's safest to just do it to arrive at the answers. And then the last question in that batch quickly powering through, tells us that, sorry, to do this here. It's almost there. Yeah, so the last question here tells us that which of the following, yes, here we are, which of the following, yeah, I think we can also, oh, I caught that, I just missed out on that. I can tell you what the last bit is, sorry. You can see the question anyway. You must have the question. Which of the following relating to CVP is true? So the last bit here, this very D is 3 and 4. D is 3 and 4. So let's see what's going on here. And which of the following to CVP, break even, all that sort of thing. Production levels are assumed to be the same. So there is no inventory level. That is true. There is no change. We don't have changes in inventory. It's an assumption. Otherwise, we would have some sort of skewed result. So typically, there's very little movement there. The contribution to sales is used to indicate the relative profitability of different products. Yes, we look at each product. Look at the C over S for each product, C over S for each product. CVP analysis assumes fixed costs will change if output either falls. No, there's never a change to fixed costs with our CVP. It's always fixed. Sales prices vary. No, sales prices do not vary at different levels of activity. We pretty much keep sales prices the same for the product. We don't even apply the learning curve angle here. We don't even, no changes to that. No. So these two are definitely wrong. It's purely a case of C over S can indicate the relative profitability of different products, because that is, C over S ratio is really like a profit ratio, isn't it? Like a profit margin, contribution margin type thing. And these are assumed to stay the same. So your answer here is C. Cool, great stuff. Another long, slightly long video. But that's question 246 done. I'll see you in 247.